So,
Okay, inverse functions. What does it mean? What does it do? All that stuff. Let's start with, let's say we have y equals 2x minus 1, or in function form, f of x equals 2x minus 1. Okay. When you say it's an inverse function, basically what that means is the x and the y values switch. That's what an inverse function does. So to find, and this is the notation for an inverse function. Okay? If this is the original function, its inverse would be written like this. Okay, how do I find an inverse function? So basically, you take the original function, y equals 2x minus 1, and you switch the x and the y value. So x equals 2y minus 1. But then we're going to turn that back into function form, which means I need to get y by itself. How do I get y by itself?
By
Here?
2.
Huh?
Plus 1. Oh,
Plus 1. Yeah, plus 1, or get rid of the plus or minus number first, and then divide by 2. Now, technically you could leave it like that, x plus 1 divided by 2. It might be useful to write it in like this form sometimes. Well, if you're graphing it, it's more useful to be in slope-intercept form. So 1x divided by 2 would be like 1/2 x, and 1 divided by 2 would be 1/2. I never know what the book's going to do. Sometimes they might put it like this, sometimes they might write like this. If you're graphing it, this is more useful. Okay, anyway, so if this is a function, this is its inverse. Now, let's see what happens when we do some stuff. Not a big fan of the eraser on this board.
Just use your data.
All right. What is, let's change colors. What color do we want? Purple. No, green. Okay. What is f of 3? There's f right there.
5.
2 times 3 minus 1 is 5. Correct. Okay. What is f inverse of 5? So this means what does the function equal? Like what is the y value if the x value is 3? That's what that means. We plug in 3 for x. So what is f inverse of 5?
No, 9.
Well, 5 times 1/2 would be like 5/2 plus 1/2 equals 6/2, which equals 3. Alright, you guys see what just happened here? F of 3 equals 5, f inverse of 5 equals 3. So it's like the x and the y value switch. So if 3, 5 is a solution for the f function, 5, 3 is going to be a solution for the f inverse function. X and y value switch. Okay, let's look at it graphically. We're going to look at this stuff from every angle. Let's see. I'm not going to remember that. 2x minus 1, 1/2 x plus 1/2. Okay. I think I just forgot it. Was it that? Anybody taking great notes today?
No.
Nope.
I think it was a minus.
It is a -1.
This is why the eraser stinks. Alright. Okay, yeah, let's graph. Yoink. Yoink. You guys know how to graph this one? Where do I start at?
It's -1.
Down 1, then I go
Up to
up to right 1. It's in slope intercept form basically. Down 1, up 2 over 1, up 2 over 1. Here's the graph. Okay, where do I start on this one? Up a half. And then from there, actually, let me change colors. Make it more visually easier to see. And then I'm going to go up 1, over 2. Rise 1, run 2. Rise 1, run 2. Rise 1, run 2. Looks like this. Okay. This is actually, these two lines are a reflection of each other over a line. You guys see the line? Yeah. It's like a diagonal. So this like reflects over here and this reflects over here. These two lines are a reflection of each other over this diagonal line. What's the equation for this diagonal line?
X equals Y.
Yeah, y equals x. Dun, dun, dun. Why is that weird? Because on an inverse function, y and x values switch. So basically they flip over this line. So it's kind of like, let's see, where do we have a point at here? Right there, that's 1, 2, 3, 4, 5. There's 5, 3. Remember we found that point earlier for the inverse function? And 3, 5 is right there on the original function. Those are kind of like the reflected points. That's the points that I found earlier when I was plugging stuff in. Anyway, that kind of gives you an idea of what happens. If, it'll get a little bit confusing if we try to do the inverse of y equals x squared. Well, actually, let's try to find an inverse function for this. So how did I find the inverse function? That's pretty sloppy Joe, isn't it? Oh, no, gorgeous. All right. Anyway, how did I find the inverse function earlier?
You switch.
Switch the x and the y. How do I solve this for y? Square root. Does anybody know what's wrong with this?
It's not possible.
No, it's possible. Anytime you use that square root trick,
It's a plus or minus.
yeah. So, you guys remember what y equals square root of x looks like?
Nope.
We just did it on the last test, darn it. We took last Tuesday. It looks like this.
Oh.
I kind of missed. It's supposed to be like right there. Looks like that. And what's negative square root of x look like? Well, it's just that flipped upside down. Yeah.
What the heck?
So it looks, together they look like a sideways parabola. What happens is, this thing kind of, I don't know if I can do it with my hand, this thing kind of flips when you switch the x and y values, it goes like this. And it is still, it's a reflection over this diagonal line, still. Like that one's reflecting there, that's reflecting down there, that's reflecting there. And that's what it looks like.
So when do we use this? Real life, when we use this?
No idea. But they're gonna expect you to know it, so I'm gonna teach it.
Why do they expect us to know?
I don't know. Don't ask me.
Cause I go against correct.
Now, a lot of math,
Wizard men.
a lot of math does have uses, and a lot, well, I'm sure you can find some way to use everything, but I've not been employed in everything.
You can use a shoe to drink water, is it right?
The more, what?
You can use a shoe to drink water, I mean, it's still weird. You need to use a shoe, or you can use a cup. But like, you know, you use stupid things.
But he said shoot your water.
Thank you, David, for your input.
Like I thought he meant like
Makes sense.
It's an ancient Indian proverb.
Okay, we probably better jump in. I've been talking for a while. We got like 30 minutes. Okay, ready? Page 341.
You know, like,
Everybody's set to go.
you use the wrong
Okay.
thing for the right task, it works out.
Number 1, it says represent the inverse as a set of ordered pairs. What did I say about inverse functions? Like what's the
Flip
key?
it.
The x and y switches. So on number 1, easy peasy, Japanese, you just need to switch all the x and y values.
If you use like the wrong things, but you get the right answer, is it right?
Okay, David.
No.
Well, everybody's looking at me weird. I don't like it.
One of these things is not one of the other.
Okay, number 3. What the heck is going on in number 3?
It's the same thing, just in the special
Okay.
thing.
But we also.
What does it mean when the arrow goes from -3 to 15?
It's negative 315.
They're saying that there's a point at like -315.
Do you also want us to put yes or no for?
Oh, did they say?
Yeah.
Oh, sorry, I didn't read D. Determine whether the inverse is a function. You guys remember what makes a function a function?
If the x values repeat.
If
it's
the x
not
val-
a function.
If all
Right.
the numbers in the domain have only one correspondent in the range.
If each x value goes to a different y value. Basically, if the x values do not repeat, it is a function. So, yes, this is a function. If it said 5, 1 and 5, 2, like the x value 5 would go to two different y values, that would not be a function. Okay, on number 3, so it says the arrow is -315, so our point is going to be 15, -3. And the next arrow is 212, so we're going to put 12, 2. The next arrow is 412, so we're going to put 12, 4. And then it goes, wait, that was all, just those 3, right? Okay, is that a function?
No.
No, 12, 2, 12, 4, that's a no-no. By the way, I would say, even though I'm not sure how you would specifically use an inverse function, that functions themselves are definitely used. That's how you program anything, basically, is use functions. That's how you speak to computers, basically. Okay, number 5, duplicate the graph of each relation. Then graph the relation's inverse and label each point of both the relation and its inverse. So, we need 2 graphs. Luckily, somebody brought me graph paper yesterday.
Can we like find them
Yeah.
and like break their kneecaps lovingly?
It's a little like 13-year-old
What a
8th
narc.
grade girl.
We get a little 13-year-old 8th grade girl to break the other one's kneecaps. I don't know, pay her off.
Hmm?
We hired a 13-year-old assassin.
Don't really expect it.
Commander.
Okay, back to the shoe though. You know, like, you ever
Stop
use-
trying to salvage this.
No one uses a shoe to
awful.
drink their water.
Exactly, it's wrong, but somebody
It's
do
wrong.
it. You know, like how like you use the wrong formula in a math problem. Like when we were doing triangles, I don't know what I did it wrong, but I got the right answer.
Oh, it's a photo map.
Kale.
No,
Sugar mama finally texted me.
like
She said she wants to make sure.
Ooh, this is like big riff.
You're really confused, but I don't want to ask.
Then she said that later she'll actually cash out, and if I'm loyal, she'll send me money.
All right, numero 5. So, oh wow, you guys' picture looks a lot different. Mine. You're just supposed to put A, B, and C on the graph. So let's do that. Just copy the graph, basically, for starters.
no.
C is at 1, 3.
Are these the only graphs that we'll have to
No,
do?
11 through 20 graphs.
Oh, that's good.
B is -4, 2. A is -3, -1. Okay, then it says graph the inverse. So, it didn't really ask us to show this, but you guys remember I said it should be a reflection over this line, y equals x. So if this C is at 1, 3, guess where the reflected C should be?
3 negative.
No, 1, 3.
Oh wait, oh,
3,
yeah,
1.
See how it like reflects over that line there? The book labeled the second C as C prime. That's what that little thing is read as. C and C prime. And then B was at -4, 2. So where is -4, 2 gonna reflect?
2 negative 4.
2, -4. 1, 2, 3, 4. Right there. Whoops. B prime. And then A. You can also kind of do it this way, like just see how it's like one diagonal step to get to the line and one diagonal step. So it'll be right there. A was at -3, -1, so it goes to -1, -3. A prime. On 6, after you draw the original triangle, just reflect each point H, G, and F, and then just connect those dots with it, and I'll make another triangle. Okay, number 7. Find the rule for the inverse. You guys remember what that meant? I didn't say rule when I said it, though. I just said find the inverse. So, how do I find the inverse?
Change it.
Switch the x and the y. So f of x basically stands in for the y. So x equals y plus 1. And then how do I solve that for y?
Give it by itself.
-1. So y equals x minus 1. Therefore, f inverse equals x minus 1. Okay, number 9. The original says f of x equals -1/2 x, or q of x equals -1/2 x plus 1. So y equals -1/2 x plus 1. So I'm going to switch the x and the y. And how do I solve that for y?
Subtract 1.
Subtract the 1. And how do I get rid of the -1/2?
Divide.
Divide by -1/2. Do you guys know what dividing by -1/2 is the same thing as doing?
Times
Multiplying by -2/1. The trick from middle school. So if we just multiply by -2, we get -2x plus 2. So I guess this one's called Q inverse equals -2x plus 2. number 11, find the rule for the inverse of each function, so that's what we just were doing. And then graph the function and its inverse on the same plane. State whether the inverse is actually a function or not. Do you guys remember by the graph, how to tell whether it's a function? You go back
If
to
you draw a line
vertical
straight
line.
down, and if it
Yeah.
gets 2 points, it's not.
yeah, a vertical line test.
Get on my level.
So, for example, a parabola is a function because it passes the vertical line test. But its inverse, remember we graphing those two things together? The inverse is not a function. It's made of two parts that are functions by themselves, but together it does not make a function. So yeah, the vertical line test is how we tell. So I guess I'll go back. Okay. How are we doing? I'm going to shorten this to 16.
Thank you.
Model legend.
Tomorrow I'm going to say the sum is 1 through 100. I'll
Oh,
change it to like
Wednesday?
1 through 25 and you'll be like,
Everyone wants to say thank you. Oh, no.
all about expectations. Okay, h of x equals negative 4x plus 1. So that's y equals negative 4x plus 1. How do I find the inverse? The rule for the inverse? Switch the x and the y and solve for y. Get y by itself. We've done a lot of minus ones, haven't we? Minus 1. Divide by negative 4. Since we're going to graph this, I'm going to put it in slope-intercept form. So this would be negative 1/4 x plus negative divided by negative is positive. And this is called h of x, so h inverse. Okay, so the original function is negative 4x plus 1. So I'm going to go up 1, the dot, and then the slope is negative 4, or negative 4 over 1. So I'm going to go rise negative 4, run 1. So I'm going to go down 4 and over 1. Remember, you can also go backwards, up 4 and back 1. That will be my original h of x. And then for my inverse, actually we could kind of cheat with the inverse and just, like if this is 0, 1, and 1, 0 is going to be, anyway, I'll just use this. 1/4 is the y-intercept, and negative 1/4, so I'm going to go down 1, right 4 for the slope, down 1, right 4, up 1, back 4. And the last question is the inverse a function? So is the second line we graphed, is that past the vertical line test?
Yes.
Yes. So I'll just put yes somewhere. Okay, number 13. Oh, that one doesn't look too bad. G of x is negative x plus 4. Where am I going? Let's go up. So that means y equals negative x plus 4. So the inverse, x equals negative y plus 4. So I'm going to subtract the 4. And what do I do about that negative right there?
You divide it out.
Divide by negative 1. So that'll become negative x positive 4. Just switch all the signs, basically. So this is called g of x. So g inverse of x equals negative x plus 4. Does that look familiar to anybody? So the original function and the inverse are the same thing. Why would they be the same thing? Let's take a look at it. Alright. You're fine. Okay, let's see. Negative x plus 4. How do I graph that?
You go up 4.
Up 4, 1, 2, 3, 4.
And then down 1, right 1.
Down 1, right 1.
Perpendicular to y equals x would be
Yeah.
the same.
So yeah, when you flip it over the line y equals x, it just happens to look exactly the same. You guys see it? You flip it this way, it's just the exact same line. That's why the inverse is the same thing. As the original. So there's only one line. Is it a function?
That's
When is it not a function? Well, 17 and 18 are those x squared problems that I did an example of. And those inverses would not be functions, but looks, I said we're only going to make it 16, so. Actually 16 is kind of weird too, though. I should probably talk about that one. 15. Little mouse. Says x minus 3 over 2. I'm going to change that to slope-intercept form. In other words, I'm going to divide both of those by 2. So y equals 1/2 x minus 3/2. That'll help me graph it. And then the inverse function, solve for y. Actually, maybe I should use the original on that. It's okay. X plus 3/2. Getting kind of fast and sloppy here. How do I get rid of the 1/2? Right, divide by half, but dividing by half is the same thing as multiplying by 2. So I'm multiplying by 2. 2 times x is 2x, 3/2 times x is 3. So the inverse function, this is called h of x again. So h inverse of x is 2x plus 3. That one. Okay, the original function was 3/2 is basically 1/2. 3 divided by 2. I'm going to go down 1/2. And I'm going to rise 1 and run 2. Rise 1, run 2. So it's kind of like that. Not my best line. I wonder if I could rotate it. Not well. Alright. Anyway, and then the other one starts up at 3. 1, 2, 3. rise 2, run 1. Or fall 2, back 1. Not gonna meet for a while. Is the inverse a function? Yeah, it is. Basically almost all lines, when you inverse them, are still functions.
What line wouldn't be?
What line wouldn't be? That's a good
so on the
question.
boundary line.
Yeah. So, number 16. So we're done with the odds, but I probably should talk about 16 a little bit. It says f of x equals -3. How would we graph that? It's basically the same thing as y equals -3. How do we graph that? You go to the y-axis to -3 right here, and then just draw a horizontal line through there. Because all of these points on this line have a y value of -3. So it's called y equals -3. When you do the inverse function, okay, how do I find the inverse again? Switch the x and y. There's only a y, so it becomes x equals -3. What's the graph of x equals -3 look like?
And they got negative.
Yeah, you go to -3 on the x-axis and draw a vertical line. So all those points have an x value of -3. Yeah. Does this pass the vertical line test? No. Fail, fail, fail. So that's the only way that you can get a no. The end.